Today I will show how to share query table data between multiple TIBCO Streaming nodes in a cluster. This will be a quick overview of the settings needed to share query table data. A cluster runs only one application, and all nodes in the cluster run the same application. Data is shared between identical query tables in each node, as long as each query table is set to use transactional memory and distribute data. Here's the application for this demo. It has one stream for writing to the table, one stream for triggering a read of the local query table, and one stream for triggering a read of the entire cluster view of the query table. All output will go to the console log for each node, so we'll watch the console to see the result of these queries. The query table is set to be in transactional memory, with data distribution settings, distribute data, which is checked or enabled, the policy name, and the mapper type. The default dynamic data distribution policy is built in and always available for use in a cluster. The only additional configuration is the client listener, so we can change the server port for each node. This is a very simple application, so there's a lot we do not have to configure. Since there's one Streambase application, we do not need an event flow deployment configuration to specify the module to run. Since we're using the default dynamic data distribution policy, we do not need an application definition to describe a data distribution policy. Since we only have one node type, we do not need an application definition to specify a named node type. Since we only have the default cluster-wide availability zone, we do not need a node deploy configuration to define named availability zones or partitions. A description of the default availability zone and policy can be found in the product documentation here. The default dynamic data distribution policy has a replication count of 2, so every query table row is physically stored on an active partition and on at least 2 replica partitions in the cluster. This allows any 2 nodes to fail without losing any in-memory row data. Let's look at the vocabulary of running in a cluster. A partition is the basic unit of data distribution in a cluster. A partition holds a portion of the data and identifies a set of nodes. A partition always has an active node and has up to the replication count replica nodes, which will physically have a copy of a query table row. A row is assigned to a partition using the mapper and by the specific configuration of the data distribution policy. Let's see this in action. First I will install 3 nodes, then I will watch their console log output, then I'll start them, then I will load data into one node and show how it becomes available in all nodes. Then I'll add a 4th node and show how rebalancing affects the data. I have opened a Streambase command prompt in a directory where I have copied the generated application archive. I install Node A and open a new terminal to watch the console log. When installing Node B, I change the node name and the Streambase server port so there's no collision. I do the same for C. I'm repositioning the windows so that we can see a bit better what's going on. Let's start each one up and watch them join the cluster. See A respond when B starts up. See A and B respond when C starts up. Now let's load our dataset into Node A using epadmin enqueue_stream. To see what is loaded on each node, I enqueue a read trigger tuple to the read input streams. First B, and we'll see the log output. This is a local read, and all rows are represented because of the replication count of 2. Each row is assigned to a partition which has an active node and 2 replica nodes. Since we have 3 nodes, all nodes are known to all partitions. Reading the cluster from node C doesn't produce any different output at this point, since all rows are local as well. Now let's install and start node D, the 4th node, and watch for rebalancing. When we do a local read from A, we see it has a partial row set. The same is shown for B, C, and D. A cluster-wide read from D returns the entire table. A cluster-wide read is not as inefficient as you might suspect, because even though some rows are remote, every node keeps a list of the entire primary key set and on which nodes that primary key row is stored. This allows the node to get remote row data directly from a near node without doing a search. Let's look at the partitions. There are 64 partitions made available by the default dynamic policy. The default dynamic data distribution policy is always available even if you've configured your own policy and availability zones. The default policy will just not be used if no query table is configured to use it. Note how each partition has an active node and a list of replicas. The specific assignments are determined by the data available, the nodes available, and the policies in use. In a custom data distribution policy, you may specify more or fewer partitions, but at least one. If you need different query tables to have different policies, create the new policy in the Application Definition configuration and specify the policy to use by name in the query table data distribution setting. If you need different nodes to be in different availability zones, create the new zones in a node deploy configuration and give your nodes explicit names and assignments. The difference between a dynamic distribution policy and a static distribution policy is that when using a dynamic policy, the rebalancing I showed can occur, and specific rows may be non-local to a node. For comparison, when using a static policy, no rebalancing ever occurs, and all nodes must be named in the node deploy configuration. This is appropriate for nodes and data which must be kept local to specific nodes for performance or compliance reasons, such as regional data guaranteed to be kept within a region. Let's stop the cluster. Thank you very much for watching this video. Please leave any suggestions or comments at support.tibco.com or visit our community site. And of course, don't forget to subscribe to our channel.